Starting. Okay. So we talked about VNC, stands for Virtual Network Computing. I actually have some handouts there that sort of reflect it. The handouts are a little old, but so the VNC is just to demonstrate again. You can actually control another machine. So in this case, I have it controlling essentially my laptop over here. So what you're seeing now on the screen is basically that laptop, and I can do things like start up Sigwin, as we've shown before. And one of the reasons I'm using the laptop here is because Sigwin in here doesn't have all the bells and whistles that I typically try to do. Okay, so I think it's time to show up. It's not showing up on. It's a demo. Of course, it's not going to work. Yeah, it just took a while, but I can actually. You can see I'm controlling the laptop to start up basically a session on a Sigwin session, again, more or less a Unix environment. The other method of actually connecting to other machines is, you may or may not have used it, it's called Remote Desktop Protocol. It's a program that is actually very useful when you want to connect to a PC. Well, I'll actually walk through this process with you because there's some software that may actually be over in Gherkin 102, which is where this class is typically held. But when I walked over there, I realized why we were not there is because they're actually doing construction or rearrangements there. I have no idea what's going on, but it sounds like the computers are still on. So I actually just tested that out. So VNC will work on both Macs, PCs, and as you'll see, Linux and Raspberry Pis. One of the reasons I show that. But if you want to connect directly to a PC, another PC, for instance, what you want to use is Remote Desktop program. So typically you can go in here and do remote desktop connection. So if you have Windows 10, it will actually be there. And so let's say you want to connect to a lap or a machine that's in another building. What you need is to know what the name is. So if you look up here, they have those names right there. You can actually use that to connect to a machine. I mean, if you want to try it later, is actually try to connect to a machine right next to you. So what you have to do is you have to give that name. So in this case, I'm going to connect to something in Gherkin 102, and it's TCA. So it's actually the machine that controls the projector. So you can try that with any of these machines. And then you want to give the ur.rochester.edu. So that basically gives you what's known as a fully qualified domain name. So if somebody says FQDN, one of those acronyms that they throw out at you, that's what they're asking for, is a fully qualified domain name. And it already logged into it, so it realizes, knows who I am. So now I can just type in my password, which should be the same. So this is actually a machine over in Gherkin. So let me actually check to see if a certain program that I want people to have access to is there. And if it's not installed, then I'll have to call somebody. Be careful when you have all these windows open, because sometimes you may inadvertently delete something from a machine that you didn't intend to. As useful as this is, you can get into the situation of not knowing which machine you're on. So I'm actually going to see if a program called NV is in here. I'll do a search on that. NV is actually no, doesn't seem to be. So I'll have to contact them about that. First of all, I want to make sure that I'm actually on the machine that I want to be on. Try that again. Yeah, they don't have it installed, so I'll have to ask them about that. But they may install it here on these machines, which will be useful. So any questions about that? So if you have a machine that has a specific program in it that isn't in all the different machines all over campus, there are some cases in that, and some labs only have licenses for certain machines. You can actually access them through this remote desktop protocol. And I just showed you that process of what one of the things you need to know is you need to know the actual name of that machine, and then the put the .ur.rochester.edu, and you should be able to connect it. So if you're, for instance, at home and you need to do some work on a machine that is that has a certain piece of software, you can do it from home by doing exactly what I showed you. So what I've shown you is two different methods. One is specific to Windows only, which is remote desktop program. If you don't have it on your machine, if you have a Mac, for instance, you can download a version from the App Store. Should have that. But if you're already running Windows, you'll already have that application similar to what I just did. So okay. Any questions about that? This is just some useful information on getting some stuff done. So let's continue where we left off. First of all, any questions about Python? Are you familiar with you're a Python? Okay, so yesterday's lecture was just strictly a quick overview of Python. So you can. Okay, how was the audio? Okay, or was it crazy?
No, I could hear it.
Okay, yeah, I don't like listening to myself. That's why I don't. And that's usually the problem is that I don't get the audio right sometimes, and I don't check because I don't know about you, but I was like, wow, people actually listen to me? Like, that's crazy. But it so good. That worked out well, and I posted the link also. I'm sort of recording this also, so you can get access to that. So let's continue where we left off. So this is one of the patterns that we saw in last Monday, and what we notice is that this pattern, basically comes up with the same pattern as the other one where we actually typed in zeros and ones. All right, so we have that, and we also notice that, and this is basically what's known as a binary version of the of this image. Right. We also can look at this one and notice that this also has use the same data, but the values are similar to that of the other image. So this is the binary version. The other version that we have is the ASCII version, which we can read, and we know that we typed in 42, 52, 62, 72, 82, and 92 for these. And the reason is that of why this works is the fact that is that it? Is that my last slide? Yes, it is. I thought I had more slides there, but let me see if I've got the other link on here. Link. Let's see if this is the right one. It's the same. But so what does this mean? Why do we have this? The reason we have this is that if we look at the ASCII table, as I mentioned before, in fact, let me jump to the VNC's lagging, so it may be that might not be the best thing to do. So let's just see if I can just fire up Sigwin here locally. And text, make it huge. Maybe it's too big. Oh, we don't have it on here. All right, let's go back to my laptop. I wish it wasn't so laggy. Oh, let me see if I can. Okay. Yeah, I hope this isn't going to be a common event here. So we say ASCII minus O for octal. And we want a decimal, right? So decimal. So if we look at the decimal values, star asterisk is 42. 4 in ASCII is 52. And greater than should be 62. H should be 72. R should be 82. And slash should be 92. So what it's done is it's actually interpreted these text values, these ASCII values, as actual numbers. Right? So we check the values up here. This is 42, 52, 62, 72, 82, 92. Now, if we look at this one and say, well, how do you get this pattern from the star, right? And the way you actually look at that is you say, if you look at what that number was 42. And if we actually use a tool in on Unix called the binary calculator, you can actually have it output in binary. So if I type in 42, so the input base is automatically decimal. And then if you look at that, see it's 10, 10, 10. And if we look at that on the image over here, if we pad it by 2, this will be 0, 0, 1, 0, 1, 0, 1, 0. Oh, I see. 0, 0, 1, 0, 1, 0, 1, 0. Okay. So you guys see where that's where that pattern's coming from. If we do now 52 here, so it'll be 0, 0, 1, 1, 0, 1, 0, 0. So what it's doing is that it's taking that same pattern and it'll display an image. Really depends on how you interpret that pattern. The reason we get this particular image is because we're taking this information and we're telling it, I want to represent this as bits instead of bytes, right? So if you actually go through and look at this pattern, you'll see that this makes sense because the ASCII values of these basically represent that pattern. Okay, so why have binary forms of data? Well, you'll notice if you actually look at the size of these files, this takes 1, 2, 3, 4, 5, 6. Okay, basically 6 bytes of information. If we go back to the other version, you'll notice that we have 0, 1, 0, 1, 1, 1, etc. Each of those is actually a character. So, and that's one of the reasons why you usually get the images in binary form. It was more out of necessity back a long time ago because it was more compact. Right? So if you have any images that you bring to a class or post on Slack that you want to play with, we can actually convert that into either form of the data that you have, right? So, but this is one of the reasons why I tell people about the NetPBM format, because you can actually look at the data in either form, in either ASCII form or in binary form. So just be aware that that's the way they exist. So, any questions about the NetPBM format? So, does anybody have any images that they want to play with? Does anybody have any particular image that they want to post to Slack, and we'll use that as a demonstration purpose? Do you have your? No, not yet. If not, I'll choose Lena, or I'll see what's on my machine. Let's see if we can find a Lena. So Lena is actually a famous test image, but recently people have basically deprecated using it because there really isn't a standard Lena image. And this is what you'll probably see. So if you look at any image processing papers that are old, they may actually show this. So let's actually go to Wikipedia and see if we can just download one of this image. So we'll be using the same standard size. So let's see. Save image as. And let's put it in that looks good. So it's going to save it as a PNG form. So let's go to that directory. Just to reiterate, in Unix, CD means change directory. So what I've done is essentially gone to that directory. PWD is to print the working directory. LS is to do a directory listing, and there's our image. So what I'll do is I'll actually rename that because Unix sometimes doesn't do well with certain characters. Okay, certain characters, although you can put spaces in it, Linux doesn't really, it's very difficult sometimes to deal with that. So I'm going to rename that to just Lena. So to rename a file in Unix is to the mv command. So mv let's look at that file name. Oh, that's because 330. All right. What I was trying to demonstrate here is the file completion in Unix. So if I say 3333, if you hit the tab, it should complete it for you. So this is something that most of you are using. If you do start it up on a Mac, it's usually what's known as the bash shell. So you can, let's rename this to just lena.png. Right. So we've just changed that name. Again, just to review, there is a file command is something in Unix that you can use. File will tell you what that is. And if we look at the NetPBM, is actually a whole bunch of libraries, all right? And it doesn't hurt to actually for you to just peruse through the different types of things that are available for NetPBM. And one of the things I usually use it for is for converting certain files to something that I could probably read. So let's actually do that. If you're on a, if you want to look at any image in a Unix system, and it's you can actually try the display command. So display, and this is something that you'll actually be using on the Raspberry Pis. So let's say lena.png. And so any Linux machine that's been well put together, display command for any images, right? This display command is actually part of something we'll talk about called image magic. Right? Image magic is actually a something that's typically distributed in most Linux machines, but display will allow you to do that. So we can see that. What we're going to do is we're going to actually use NetPBM to change some of the characteristics. So there is a PNG, or let's see, is there PNG to PBM, PGM? And if you're not familiar, if not sure if a command is there, you always use what's known as the which command. In Linux and Unix, which command basically says, do I know what? Do I recognize the command that you're about to type in? So if I said which display, it'll tell me where on your system it's actually getting that program. All right. So if I say which PNG to PGM, it says it doesn't find that. So let's try PPM. Oh, let me see. Oh, which okay, which, oh, I know what it is. PNM. Yes. Okay. So we talked about the three types of images: PBM, PGM, and PPM for color. Now, the syntax that we have here, PNM to PNG to PNM, basically says that I can take PNG and write it out as either I can write it out in, no, sorry, it's been a long day for me. So we can take that image, that PNG image, and it can be generated into either a PBM, a PGM, or PPM. It really depends on what that image is coming in as. So let's actually go ahead and convert this. So PNG to PPM. And then the way this works is I would say lena dot PNG. Right. And this is where it gets a little strange, because the way this works is that it will actually, if I just did this and hit return. Oh. Come on. Right, getting all this garbage. Okay, what's it doing? It's actually converting this into binary it's spitting it out as binary form. If we wanted to save that binary, and be careful doing this, it just usually screws up your machine. If I wanted to save this file, I can call it Lena, and we'll say this is, actually, let's actually see what, there's a command called pnm file. And what this is telling us is that this is a 330 by 330 ppm image. So it knows it's a color image. And let's actually save this out. So this little, I don't know if you guys are familiar, probably not familiar with that, but this is what's known as a piping operator, right? So let's actually save this out as an image. To save it out using these utilities, you would say greater than, and then we'll call it Lena, and we'll call it P6 dot ppm. Right. If I wanted to write it out as an ASCII with in a form that we can read, you give it the option So now we go to the PNG. I know it. The option is actually no raw. And again, we talked about the man page. I believe that's what you would. Let's do the man page. Man on PNG to PNM. So it converts it to that. Let's see. Verbose alpha. So I think I might have to go from PNM. No raw. Yep. So what this simply does is PNM no raw, and I'm going to take the Lena dot P6 dot ppm, and I will convert that to Lena. Oops. P3. What did I just do? Well, I converted this from binary to ASCII. If I actually look at this file, red, green, blue, red, green, blue, red, green, blue, red, green, blue. So you can actually see this. You can actually see the pixel values in this form. If we actually try to display this, Lena dot P3 dot ppm, same image. Okay. Same image. Just to show you this, if you click on this guy, it will allow you to do image magic. So there's a whole bunch of other options for manipulating this, but I just use it for display for the most part. So we'll go ahead and get out of here, but we'll cover that a little more. So there's PNM file will help you interrogate a particular image that's in PNM format. Right. So you can see that it's a plane. That means it's all it's just text data. If we look at the 6, the other form, it'll tell you that's raw. If we actually check the size of this, of the two files, okay. Right. You'll see that this ASCII form is significantly larger than the other one, and that's why you typically will get images in binary form, because it's a lot more compact, but not as convenient for a person to look at the values. So sometimes, but people who want to actually see the numbers may want to use this specific format. But just be aware that that's one of the reasons why you have those two types of formats. Now, if you want to convert one of these guys to something that's a little more common, a JPEG, for instance, you can actually say PNM to JPEG, and then you can say Lena, yeah, either one of those, p6.ppm to Lena.jpg. Oops, and I have to redirect it, because if I don't, it'll go straight to, right? So now I can display that also. It's the same thing. So there's other values that you can, other things that you can do to this. So there's, I believe, a ppm to PGM. Sorry, ppm to PGM, Lena P6, then we'll redirect it to Lena.pgm. What did that do? I say display Lena.pgm. I just convert it to a grayscale image. And if I'm not sure if there's a PGM to PBM, but let's take a quick look. Oh, okay. So let's try that. But there are different types of options here. I'm just going to go default here and say PGM to PBM, then Lena.pgm, and then redirect it to Lena.pbm. All right. So you can do all this in Photoshop if you want, but this allows you a way of actually sort of scripting out anything that needs to be done repeatedly. Oh, okay, that didn't work. Let's look at the, when it doesn't work, that's when you look at the options. PGM to PBM. So let's see, there's different things that I don't remember. Let's use there's an algorithm called the Floyd-Steinberg half-toning algorithm. You just need to know that it exists. So let's do PGM to PBM, and that was minus Floyd. Dot PGM. Lena-Floyd .pbm. Let's look at that. Nope, still didn't work out right. I'll have to figure that one out. You can actually do a PNM histogram. So you can say PGM hist on Lena.pgm. And basically it gives you a histogram of the gray values, the occurrence of those. So if we look at the beginning, so this is telling you what value is in the images and how often it occurs. So this is similar to what you would see on a in ImageMagick, or not ImageMagick, in Photoshop or GIMP. If we actually read these in, you can look at the histogram, how often each of those pixels occur. Right. So this is just a way of extracting that data. One thing also that it does, that you should be aware of, that it does, is to actually do a PM hist of the color data. And because I didn't give it the right name. And this is a big one, because what it's basically doing is it's telling you how often a particular color exists. And if you think about the combinations that you have red, green, and blue. You have to go through 0, 0, 0, 0, 0, 1, and so on and so forth. So how many combinations do you actually get in a color image? If you've got 8 bits, and 8 bits, the number actually turns out to be 16 million possible colors. Right? So you have 16 million possible combinations. Not all those combinations exist, but the PPM hist will actually give you that statistic. It'll actually figure out how many colors are there and give you the occurrences of each one of those colors. So there's a couple of things here that probably I skipped over, but let's just talk about them. So the redirection operation. Right? So if I just say ls, things go to the screen, right? Or I can actually send it to a file. So let's call this ls my directory .txt. What did that do? Well, all this actually did in Unix, this greater than basically just says, take whatever came to the screen and put it into a file, right? And name it this file name. Right? And that's what's known as a redirection operation. The other operation that that you want to be aware of is the piping operation. So basically what that does is it takes the output and essentially pushes it to another command. So there's actually a command in Unix called WC, which actually will become fairly useful, called word count. And what that tells me is that that command will generate 28 lines, 32 words, and 619 characters. If I do the same command on my directory, it should be the same, because you basically use this as a temporary location for the output of ls. So one thing that you can do with NetPBM is you can start stringing all these different commands. So if I now wanted to convert that PNG file, if I want to look at my history, just so I can remember what I did. So I had a PNG to PPM, or PNG to PNM. I converted it to some file, but then I piped it to tell me what the values are. Well, you can start doing something like this, where you can say PNG to PPM, and then lena.png. And this time, let's actually do a PNM scale. And if you give it a value of, let's scale it up to by 3, right? And we can actually then display it to the screen. Oop, oop, what did I do wrong? What did I do wrong? Oh, it's not found. I used the wrong command name, but PNM. So what we did here just is in a single command line, we told it to, we told it to convert it from a PNG to essentially a PPM. And then we said scale it by 3 and then display it to the screen. So in one command line in Unix, you were able to concatenate all those operations. And what people will typically do is they'll actually put this command either as an alias. Let's actually stop this now so I can get to it. Okay. VNC is just being slow. Right. And look at my screen there. It actually finished that. Yeah, I hope it was working fine yesterday, so I don't know what changed today. There you go. So you have this command here. What some people will do is they'll actually put that as as an alias or something like that. So aliases are things that allow you to and I don't typically use aliases, directory, or let's say dir, for those of you who are, and then you say ls minus l. Like I said, I don't use it too often. That's what it is. So it's sort of a crutch. I don't recommend people use aliases, but people will actually do that sometimes if they want to rename a particular Unix command to do that. What we'll be talking about later is to actually talk about bash scripts. That'll come in handy also with dealing with a large number of images. So again, I recommend just doing a looking at NetPBM and just seeing all the different operations that you could do with this. And a lot of the things we'll revisit again when we start talking about ImageMagick. Okay, ImageMagick. The way I look at ImageMagick is it's more of an update to NetPBM. So the NetPBM utilities are numerous. I just touched on a few of them. Come on, I just wanted to get to the end and see. Oh, they don't show much in terms of the different. Oh, I know what it is. PPM. All right, that's what it is. So if you type PPM, you get to see all the different processes that you can apply to a color. And at the very bottom, and it gives you an example of that. So if you forget how that looks like, do a man on PPM, and you'll have a whole bunch of programs that process that. Let's see. And okay, they don't have this here, but you can go on Google and look at the do a search on NetPBM, you'll get all the different operations that you can do with NetPBM. So, any questions with that format? So this is sort of a once you know NetPBM, you can convert almost anything. So there's a whole bunch of converters in the NetPBM utility that brings it to the NetPBM format. Then you can go out to different ones, TIFF, JPEG, as you've seen there. We did PNG, JPEG, PBM. There's a whole bunch of them that you can use. So typically that's why I tell people, use NetPBM. And if you need to read it into a program like Python, for instance, and you don't want to deal with binary data, write it out as a raw file, and you can just read the ASCII values, similar to what we did yesterday, where we actually opened up the file, read in that string, and then basically converted it into values. And we also showed you yesterday how to do a quick histogram in Python using dictionary data structures. So just to give you a sense of that. All right. Any questions? So let's go ahead and actually break into the Raspberry Pis. Mike has a lot of expertise in this. Apparently he has like 5 of them.
I do not have expertise. I just
so just to give you, there's a, let me post these directions that we used last year. So which is actually just a decent, let me just go to the last year's site and put it in there. But go ahead and pick one up. I do recommend that you put, you also have put your email address, write it directly on both units, both the containers, so that you have it. Oh, dang, I forgot I have to go back to the office. I want to get the thermal camera to give to somebody to play with. So,
you want us to write directly on the box?
you can. I'm more concerned about the fact that if you leave this somewhere, somebody can return it to the box. Yeah, put it on the box too. What the heck? All right. If you guys can get started with that, let me actually before I leave, I'll be back. But you could. And our goal for today is just to get stuff running and show you how to customize your environment. So that next week, we can actually start playing around with simple CV. Here we go. So I just posted a link to general that you might want to look at. It's basically a setup that one of the students found for setting up the i7. So I'll be back. I need to I believe I forgot that. You guys have keyboards and mice here for initial setup, so just so you know. I think we showed one keyboard. Who has Apple iPhone? No?
Yeah.
Oh, you guys do? So you don't have. So maybe I could sacrifice one for a future week. What I'm going to do is I'm basically going to let you, each of you play with this for a week. I want you to just take pictures and have a little post what you've taken pictures of and tell me what you think you see, etc. So this is basically a thermal camera that people can now buy for $200. Used to be $100,000, $200,000. So who wants to play with it first? Have it for a week. Okay, there we go.
The first one is little black tab. When you connecting this in, you have to push them back in.
We're just
Let's do that again. So like with these, we got pull them up here. When you put the
when you put it in,
And you
and
snap
when you
it
push it, when you push it down, it'll bite into the ribbon cable. Like I said,
Took some
good.
and of course I forgot to bring my Raspberry Pi, but we'll get you guys going. So this is.
Sorry.
Coming from. So when you get to a point where you actually get it all fired up, there's a couple of packages that you want to try to install. ImageMagick is one of them, and I can't recall if they have NetPBM, but NetPBM would be another one. And the last one, I'm trying to remember what the third one should be. It's escaping me right now. But the last one you want to do is also Simple CV, which will be the tool that we'll be using with the Power?
No,
Oh.
keyboard.
Oh, yeah, there you go.
Thanks.
Keyboard and mouse.
Should have started it before.
What's that?
Oh.
Power.
You know, is it from 1 and 3?
Yeah. So one starts closest to you. It's no, it goes over.
Okay, so it's 1,
2, 3. Yeah.
so then those things back up here.
I
So that's
forget if
the
it's snakes. Yeah, I don't know.
So,
But the third one is definitely that one, definitely.
I've screwed it up before. The third one was. Check my notes. Actually, let me check the last year's notes. So if you check the general, I'm posting some things that the students found as they went through this on the Slack. So that let me check the last command is accurate. Let's check.
Where do you put this? Uh,
Oh, so actually on Slack, I think I posted something on rotating display. Oh, is it on your, which one is it? Yeah, there's I think, check on Slack, I just posted something from last. I think there is.
And then it's for the water. And yeah, so the button, that wire should power the board. So power the panel. So
So I made several posts on the general of Slack, and the last one is basically running a simple CV Python files. So let's try to make that the goal of getting things done for tonight. If you don't get that far, that's okay. It's just a goal. I know that this often does not always work out the way you want it to, but that's part of the process. So yeah, those are the things that you want to install, and then there's also stuff on the general channel on Slack if you want to look at.
So you don't need do you need a keyboard and a mouse?
Yeah, it'll be easy for the first time. Then what we're going to do is actually, I don't have my machine here, but one of the things you want to install also. I forgot.
should we do like updating everything?
Yes, do an update, and then also I don't have that here, but let me make this smaller. You'll have the keyboards for now, but the one thing that you want to do, and you can do this, is install Real VNC Connect through the browser. And that's sort of the application that I showed of how to control a different machine. So, question?
I'd have to log in at all. I just kind of went here because that in the videos.
Well, we already have Raspberry installed on the.
Yes, on the card. Yes,
Yeah.
correct.
So,
That was one of the things first mistakes I did is like have people try to download it. I was like, oh my god, that was a disaster. That was a total disaster. So I learned to just like get it on the card.
yeah, it's hard to.
Yeah, it was. Like I said, it was a disaster. So I can take the boxes,
Yeah, if you want.
the empty ones for now, so that and then
So before we do any of that, we should probably do the update, right?
yep, that's the point. So put that up there.
So when it's on Facebook, I go into like, is there anything that's got to
The X is like up.
I do want it. Pretty brief, pretty simple.
So unfortunately, there's no good place for us to keep the boxes, so you may have to be carrying it back and forth. But if you have some place safe to put it, that'd be helpful for you. But they'll become your friend for the next 6 weeks, next 5 weeks.
So like a little toolbox, right? That's what we want to be carrying around.
Yep.
So this, like, what would you call? So this is basically just like a physical version of a shelf for you with a lot of things installed, little like plugins. Like, what would you define like this as a Raspberry?
Raspberry Pi.
What's it for?
What's it for?
Yeah, so I've worked with like Arduino. And stuff,
Yes,
so, like,
it's very similar. It's well, not I don't want to say similar. Arduino is better for real time processing.
Okay.
But the Raspberry Pi is a little more of an actual real computer. It's a Linux system.
Right.
So one of the things that people have been doing now in order to be somewhat useful is actually to push the hat, what the what's that? It's probably a heat sink. Oh no, what's that?
Other than that,
We lost the script.
Oh. That happens a lot. I might, if you guys are missing anything, let me know, because we do have some open ones that open kits that I can take spares from.
so these are just heat sinks.
Yeah, those are heat sinks. We're not going to be doing any heavy CPU intensive processing. I don't know why they. Okay, so you connect everything and then you can. Yeah, but I could save all the times I had to switch the USB cable. Got the keyboard on. Yep. Right off the yep, terminal. So it's
Yeah.
that's the password. Yep.